So now we want to get a perpendicular bisector of a line segment. So in order to do that, what I'm going to do is I am going to make 2 points, one above the line and one below the line. And so, and all of these measurements will be the same. So if you can get your compass to stay completely equal, it would be good. So you're going to make an arc from B above the triangle and, above this line segment and below the line segment. So that would be, see if I can see where it is. It looks like here and here. Let me make sure that that's correct. So from B up here and B down here, okay? Then I'm going to do the same thing from A. So I'm going to draw an arc here and then again down here. And so this one looks like this, and this one looks like this. And notice I'm going to have to kind of extend my little arc a little bit because I didn't make it long enough. Oh, I think I had my pen in my hand too. Okay. So I'm going to have to extend this arc just a tad to make it hit the other arc. And so here's point P and here's point Q. And then I just draw that line, and that will give me point P and point Q, give me a line that is perpendicular to line segment AB. Now notice what we're doing. We're actually making a rhombus here because this is the same distance. Notice all the distances are the same. So this distance and this distance are the same, and the distance from A to Q and B to Q, all the distances are the same, all right? And so since all the distances are the same, then that's going to be a rhombus. Notice that the two lines are these two lines are parallel, these two lines are parallel. And so it is a parallelogram. And in a rhombus, the diagonals bisect are perpendicular bisectors of each other. And so that makes this a perpendicular line. Okay? And so that's how you create a perpendicular bisector. And notice that the compass does not move. All right? Now, let's bisect an angle. Okay, so bisect an angle means cut it in half. So we want one half to be the same measure as the other half. And so in order to do that, what I'm going to do is I am going to draw an arc. Let me get my paper kind of tilted a little bit here. So I'm going to draw an arc, just any arc. It doesn't matter how long it is. I'm not going to make it too big. So I'm going to draw an arc from here and all the way around to here. Let me see if I can keep that so it's this point and this point. And then my arc look like this. All right. So it just says draw an arc from A to define B and C. All right. So that's what I did. I just made all one big arc, and that defines B and C. And it doesn't matter how far out B and C are, it'll still be a perpendicular, not a perpendicular, we're going to make sure that it is the same length from B and C. It doesn't matter, as long as these two lengths are the same, it doesn't matter how long it is. So then I'm going to take an arc from C, and I am going to draw that arc. And again, it doesn't matter how big it is, and it doesn't matter where it hits this big triangle. This big arc. So from C, I'm going to make an arc. So draw arc from C, then the same distance from B. And so then the same distance from B. And that defines point P. Where these two arcs meet defines point B. And then if I draw a line from A to P, this little angle and this little angle will have exactly the same measure. Now again, on the test, what I'm going to be looking for is, did you make an arc here? Then did you make an arc here and make an arc here? And then did you define P and draw your line? So you just make any arc here to define B and C. And then if you want to make your compass a little bit smaller or keep it the same length, it doesn't matter. I just kept mine the same length. And then I measure from here to here and here to here. So the point is that this length here has to be the same as this length here. And when you do that, then where those two meet, notice it's not where it meets this big arc or where this one meets the big arc. That's a different point. This one right here, where these two arcs from B and from C intersect, that's point P. And that gives you your angle bisector. Now, let's say we want to make a perpendicular line through a point that's not on the line. All right? So what I'm going to do is I am going to, notice it's very similar to this one, but I don't have points A and B. So what I'm going to do is I am going to make points A and B. So I make an arc from point P that goes through this line. So let me turn my paper a little bit. So let me make it a little bit smaller. So I'm going to just make an arc through P. All right. And notice sometimes it's easier to turn your paper than it is to turn the compass. And so here's this little arc. Okay? So now this is my point A and this is my point B. So make an arc through the line from point P, and that gives you point A and B. Now, I'm going to take the same length, so now all I have to do now is find point Q. So I have the same length from P to B is going to be the same length from Q to B. I'll turn my paper down here, and I'll make my little arc here. And then it's going to also be the same length from A to P. So I'll turn my paper, I'll come down here, and I'll make this one. And again, I didn't make my arc from B quite long enough, so I'm going to extend it a little bit. Oops. And so that defines point Q. So once I have point Q, then I can draw my perpendicular line. So this is a perpendicular line through a point that's not on the line. So what I have to do is get A and B first, and then it's the same as it is up here. And again, on the test, what I'm going to be looking for is this little arc defining A and B, and then these two little arcs defining Q. And that is how you do a perpendicular line through a point not on the line. So we have two more, and I'm going to do those on another video.